Hello everyone. Today's video we're going to use technology to show you how to predict the linear model. So in this example, the table below shows the number of cricket chirps in 15 seconds and the air temperature in degree Fahrenheit. Plot this data and determine whether the data appears to be linearly related. So one way you can do is you can use Excel sheet or you can use other graphing calculator. In here, I'm going to show you how to use GeoGebra. So the way to do it is you open a Google and then type in GeoGebra Classic. It has to be Classic. After that, you are going to add a spreadsheet, or I'll choose probability first. After the classic, in here on the upper top, you will see a triangle. After triangle, you see 3 dots and choose spreadsheet. In the spreadsheet, you're going to type in the data. All right, so our data is 14.4. Let me type this in very quick. Okay, I already finished typing in the data. As you can see, the first column is going to be the input, which is the cricket chirps in every 15 seconds. And then the second column is going to be the corresponding temperature. All right, so after you've done that, you highlighted these two data and choose on the icon on your upper left. On the upper left icon, you will have one variable or two variable regression analysis or multiple variable analysis. Since we have two variables, one input variable, the other is output variable. So we're going to choose two variable regression analysis. And then they will plot that for you. So after you plot the data, it appears that there may be a trend. So that trend it really looks like a linear, although certainly not perfect linear. In this case, what you can do is we can approximately this is a linear to see which line is going to be the best fitting for this model. Well, as you can see, for the linear regression model, they have different options in the drop-down menu. You can choose linear, logarithm function, or polynomial, and so on, different model. So since right now we are focused on linear model, let's choose linear and see what happens. And then the graph, the GeoGebra will give you the best fitting model to these data. What does that mean? What is the best fitting model? That means this model gives you the best result that to represent this data set. In here, it gives you a function in the lower here, y equals to 1.1320 below the graph, right? And then on the upper corner, if you choose this show statistic, upper right corner, they will also give you different things, such as the mean of x, the mean of y, which is the mean of your first column, the mean of your second column. And then the most important thing is the R value. So the R value is represent the correlation between these two data. I am going to explain it to you later. So right now, in this video, I'm teaching you I just taught you how to use GeoGebra. So the couple of things that is important is the model that they give you, which is a linear model, which they give you the equation with m equals to 1.1432, and the b, the intercept, is 13.2806. And also, they can also give you the statistic, where it shows you the R value and R square. Okay. In here, I am going to explain it to you how to read and interpret this data. Okay, so from the early example, we got our function y equals to 1.1432x plus 13.2806. Remember, our input x represent the characters in every 15 seconds, and then the output is the temperature. So that means in this function, they have this relationship when y, the output, is going to equal to 1.14 times x plus 13 will be the y-intercept. And they also give you the r equals to 0.9509, r squared equals to 0.9043. Okay, so let's break this down. So r is called the correlation coefficient. So r is called correlation coefficient. So the value of r is going to be in between 0, not 0 to 1. It's going to be in between -1 to 1. So if r is positive, that means the correlationship is going to be an increasing relationship. So if r is a negative number, that means this is going to be a decreasing relationship between x and y. So what does that mean? So in the graph, this most likely is going to look like this one. The bigger the x is, y gets bigger. This means they have an increasing relationship. Well, when r is a negative, that means this relationship is going to be decreasing, more like look like the graph of that. As x gets bigger, y gets smaller. All right, so what does 0 to 1 means? So if r is closing to 1, that means they're strongly related. If r close to 0, that means their relationship is really weak. For example, if you see the dog look like this one, so that means r is close to 1. Right? Because you can see this is a linear. But if when you plot in the function, it's more look like this one is really scattered. You can see how it's still increasing. They still have a positive relationship. But however, they're really spread out. So that means r is going to be close to 0. On the other hand, for a negative one, if a function look like this, almost like you can see a line, so that means r is close to -1. But if you see a function look like, hey, it's really scattered, that you barely see a straight line, then I will say, hey, r is close to 0. So that would be the relationship. And then another important concept is called interpolation and interpolation. So interpolation in this means is when we predict the value is inside the domain and the range of the data. So extrapolation means when we're predicting a value outside of the range, and the domain of the data set. So for example, in earlier we have the data chirps. We already have our predicting model in here, which is y equals to 1.1432x plus 13.2806. So the data when we gather, we have the chirps from 18 times per 15 seconds to 44 times. So that means, hey, if we try to predict the temperature, like what's the temperature if the cricket chirps 13.5 times? Let's say the domain. Let me write this down. So the domain that the data we're connecting, we have is from 18, approximately 18 is the smallest one, to 14.4, and the range, the temperature we connecting from the data is 15.3 to what? 18.5, let's say 18.1. So that means if we're trying to predict, hey, how many, so if the cricket chirps 13.5 times, right? 13.5 times is still within the domain. So when you predict them, it's still with the range with this model, right? When you predict them with this model. So this is called interpolations. But if I'm trying to say something, hey, so right now the temperature is 100 Fahrenheit. I want you to predict in how many times does the cricket chirps. So 100 Fahrenheit is outside of our range, right? So that means this is extrapolation. Okay, so that's it for the linear fitting model. So in your homework, you will see lots of given data set and want you to do some prediction problem within the model generated by GeoGebra or other graphic calculator that you use. It's very interesting. So please do some of your homework and let me know what do you think about this section.